Introduction: A world with two suns. Right now, as you watch this video, there's a blue sky above your head. When you breathe, a mixture of 78% nitrogen and 21% oxygen fills your lungs. The air pressure outside is 1013 millibars. The temperature is probably between -40 and +50 degrees Celsius. Gravity pulls you down at 9.8 meters per second squared. These are all conditions your body has perfectly adapted to through billions of years of evolution. But now imagine. You wake up on Mars and look out the window to see two sunrises. One is our sun, but only 43% the size it appears from Earth, pale, distant. The other is artificial, a second sun, reflected from giant orbital mirrors. The sky is reddish-orange, but there's a bluish glow on the horizon. When you breathe, actually, you can't breathe. Not yet. But in 2157, you will be able to. According to NASA's Mars atmosphere data, the planet's atmosphere is 95% carbon dioxide, with pressure only 0.6% of Earth's. Temperature varies between -125 and +20 degrees Celsius. Gravity is 38% of Earth's. The human body cannot survive here. At least, it can't survive here now. But in NASA's files, there are plans not yet fully shared with the public. Plans to make Mars habitable. Terraforming plans. Some are so detailed they've calculated which year, which gas will be released into the atmosphere, where the first ocean will form, when the first rain will fall. Joint efforts by SpaceX, Blue Origin, and NASA are mapping out a process to begin in 2030. Today I'll show you two versions of Mars. First, the Mars we know from NASA's Mars Reconnaissance Orbiter, Curiosity, Perseverance, and InSight missions. The red, dead, cold desert planet. Second, Mars, in 2157, in the 207th year of terraforming, where the first permanent cities have been established. Clouds form in the sky, and 1 million humans live, ready to see how the red planet becomes the blue-green planet. Then let's begin. Because this story isn't science fiction, it's a carefully calculated future projection. Part 1. NASA data. Mars's current state. Anatomars, autopsy of a dead planet. From NASA's 50 years of Mars research, we know Mars was once very similar to Earth. 4 billion years ago, it had oceans, rivers, a dense atmosphere. So what happened? The magnetic field catastrophe. Mars's core cooled and solidified. Unlike Earth, Mars has no plate tectonics. Result, the magnetic field collapsed 3.5 billion years ago. Without a magnetic field, solar winds slowly stripped away the atmosphere. According to NASA's MAVEN mission data, Mars still loses 100 grams of atmosphere every second. Current atmosphere data, NASA Mars Atmosphere and Volatile Evolution Mission, pressure, 610 Pascal, Earth, 101, 3025 Pascal, composition, 95.32% CO2, 2.7% N2, 1.6% argon, 0.13% O2. Water reserves. Mars Reconnaissance Orbiter. Radar data. NASA's shocking discovery. Mars has enough water to fill Earth's Atlantic Ocean, but it's frozen. North Polar Ice Cap. 1.6 million kilometer Thukrib water ice. South Pole. 1.5 million kilometer Thukrib water ice. Plus dry ice. Underground glaciers. 5 million kilometer Thukrib water ice. MOXIE, Mars Oxygen, In Situ Resource Utilization Experiment device. With 10 grams O2 per hour production, 99.6% purity. Energy consumption, 300 watts. Human daily need, 840 grams O2. The math is simple. 84 MOXIE devices can keep one human alive. 84,000 devices can sustain a colony of 1,000. Mars days and seasons. Sol, Mars day, 24 hours, 39 minutes, 35 seconds. Only 2.75% longer than Earth. Human circadian rhythm can easily adapt. Mars year and seasons. 687 Earth days. 669 sols. Axial tilt, 25.2 degrees. Earth 23.5 degrees. Distinct seasons, but very extreme. NASA's Opportunity rover shut down in 2018's global dust storm, when light reaching its solar panels decreased by 99%. These storms can engulf the entire planet and last for months. Radiation. the silent killer. Radiation on Mars is 100 times Earth's. NASA's Curiosity Radiation Assessment Detector, RAD measurements. Surface, 0.67 millisieverts per day. Per year, 240 millisieverts. Earth annual limit, 1 millisievert. Astronaut limit, 1,000 millisieverts. Career, 4 unprotected years on Mars. Maximum career radiation dose. Cancer risk increases by 5%. The perchlorate problem. Phoenix Lander's 2008 discovery shocked the scientific world. Mars soil contains 0.5% perchlorate. This chemical, toxic to humans, affects thyroid gland, lethal to plants, keeps water liquid at -70 Curie, but also used in rocket fuel production. NASA's solution. Special bacteria eat perchlorate and produce oxygen. Dichloromonas and azospirobacteria naturally do this job. Dust storms and static electricity. Mars dust particles carry 10 times more static charge than Earth's. According to InSight's measurements, Barno electric field up to 150 kilo. Earth storm 3 kilo. NASA's Mars 2020 helicopter Ingenuity made 72 successful flights thanks to special anti-static coatings. Part 2, Terraforming process. Scientific roadmap. Phase 1, atmosphere thickening. 2030-2050, melting polar caps. According to NASA's calculations, if you melt the CO2 ice at the South Pole, atmospheric pressure doubles, 12-20 Pascal. Greenhouse effect begins. Average temperature increases by 10 Gress. How to melt. Orbital mirrors, 225 miles diameter, 100 tons weight. Aluminum mylar mirrors. Each can focus 1 gigawatt of energy. 100 mirrors. 1 polar cap melts in 20 years. Super greenhouse gases. MIT's calculations show each ton of SF-thick sulfur hexafluoride released into Mars's atmosphere creates greenhouse effect equivalent to 23,000 tons of CO2. 100 factories. 1 million tons. SF-thick per year. Average temperature plus 30 NOx in 50 years. Asteroid redirection. Ammonia-rich asteroids C-type redirected to Mars. Each 2-kilometer diameter asteroid grow 10 trillion tons ammonia. Impact energy 130,000 megatons. TNT. Released greenhouse gases and water vapor. Local temperature increase plus 3 degrees free. NASA's calculation, 40 asteroids, Mars average temperature reaches 0 degrees free. Phase 2, magnetic shield, 2050 to 2070. Mars's biggest problem, no magnetic field. The solution proposed by NASA's Planetary Science Division Director Jim Green in 2017 is real. IL-1 Lagrange point. Magnetic shield. A giant electromagnetic generator placed at the balanced gravity point between Mars and Sun. Magnetic field strength, 2 Tesla, diameter 60 miles. Energy requirement, 10 GW, 10 nuclear reactors. Protection area, all of Mars. Result, atmosphere loss stops. Radiation decreases by 90%. Greenhouse gases begin accumulating. Phase 3, oxygen production, 2070-2100. Cyanobacteria. Bombardment. The organisms that added oxygen to Earth's atmosphere 2.4 billion years ago. Cyanobacteria. NASA's Ames Research Center has developed strains resistant to Mars conditions. Radiation resistant. Deinococcus radiodurans genes. Cold resistant. Antarctic strains. Can process perchlorate. Converts CO2 to O2. Mathematics, just 1 gram cyanobacteria. 1 milligram O2 per day. 1 kilometer quadtread pond. 1,000 tons O2 per year. 100,000 kilometer quadtread. 1% O2 atmosphere. In 50 years, Sabatier reaction factories. CO2 plus 4H2. CH4 plus 2H2O. Then electrolysis. 2H2O. NASA's Mars design. CRUM. 1 factory, E100 tons. O2 per day. Energy, 50 megawatt solar or nuclear. 1,000 factories, 10% O2 in 50 years. Phase 4, water cycle, 2100-2130. First rain. When atmospheric pressure exceeds 10 kPa, water cycle begins. Evaporation. Cloud formation, 5 to 10 kilometer altitude. Precipitation. First snow, then rain. NASA's climatology models. First rain in 2027 in Mariner Valley. Part 3. Albany Jang's story. Mars 2157. Prologue, third generation. March 7, 2157, 06:15 hours. Mars Standard Time. Olympus City, at the base of Olympus Mons. When Albany Jang opened her eyes, she saw Phobos's rapid transit through the ceiling window. Mars's inner moon rose in the west and set in the east, 3 times a day. People from Earth could never get used to it, but for Albany, it was normal. She was born on Mars, 23 years old, third-generation Martian. Her grandfather had arrived as one of the first colonists in 2089. Her father was first-generation born on Mars in 2116. Albany was born in the 1207th year of terraforming, on a Mars where you could now stand outside for a few minutes without a pressure suit, where thin clouds formed in the sky, where greenish moss plains appeared on the horizon. Height, 6 feet 5 inches. Mars's low gravity had shown its effect over 3 generations. Very tall by Earth standards, very thin. Bones 30% less dense than Earthlings, but perfect for Mars. Muscles developed differently. Strong legs could jump 20 feet, but upper body weak by Earth standards. Albany was studying atmospheric engineering at Olympus University. Today was special, test day for the Great Rain Project. The project that had been prepared for 30 years would create Mars's first artificial rain cloud. Olympus City, 257. Looking out the window, the view was completely different from her grandparents' Mars. Olympus City was built at the base of Olympus Mons, 13 miles high, the solar system's tallest mountain. Why here? Because altitude, less radiation, volcanic soil, mineral wealth, slope, natural wind barrier. The city consisted of 7 interconnected domes, each dome 3 miles in diameter, 1,640 feet high, made of transparent aluminum graphene composite material. Total population, 125,000. Total human population on Mars, 1.2 million, in 27 different cities. The weather display showed the day's data. Rano outside temperature, -5 dull, 127 years ago. -63 go. Atmospheric pressure, 12 kPa, 127 years ago. Knee 6 kPa. Thanks to magnetic shield, wind 15 km/h. From west, outside still required an oxygen mask, but no longer heavy pressure suits. Thin, heated clothing and face-mounted oxygen concentrators were sufficient. Hands and face could survive exposed for a few minutes. Cold, but not lethal. Morning routine, being Martian. Albany got up and went to the kitchen. Breakfast menu was entirely Mars-produced. Spirulina algae-enriched cereal from Mariner Valley Farms. Synthetic milk, precision fermentation, bacteria-producing milk proteins. Vertical farm tomatoes from Olympus's 47th floor farm. Water came from the tap, purified from polar glaciers, mineralized. Tasted different from Earth water, more metallic, slight perchlorate taste despite triple filtration. News channel headlines: New water reserve discovered in Utopia Planitia, 50 million kilometers through keep. 4%, 2030 Mars, 100% Earth conditions. Average progress was 0.8% per year. Journey to university. Albany left home and walked to the metro station. Olympus Metro operated with vacuum magnetic tube system. Without air resistance, it could reach 375 mph. It crossed 7 domes in 15 minutes. She observed different generations in the metro car. First generation 70 to 90 years, born on Earth, still speak with Earth accents. Second generation 30 to 50 years, born on Mars but raised with Earth culture. Third generation, drew Martians, know Earth only from videos. Physical differences were obvious. Each generation taller and thinner than the previous. Thicker eyelids, evolutionary adaptation for radiation protection had begun. Lung capacity 20% larger, adaptation to thin atmosphere. Atmospheric engineering class. Professor Chen, Earth-born, 67 years old. Today's topic, the Great Rain Project. 227 years ago, Mars's atmospheric pressure was 600 Pascal. Today it's 12,000 Pascal. How was this achieved? The hologram showed Mars's transformation process accelerated. 2030-2050, Warming phase. 500 orbital mirrors deployed. Polar caps 40% melted. Average temperature rose from -63 true to -30 true. 2050. Thickening phase. Thickening phase. 50 asteroids redirected. SF-FIC factories established. Atmospheric pressure increased tenfold. 2070-2100. Life phase. Rofus-Moss plains spread. O2 level from 0.1% to 3%. 2100-2130. Water phase. Northern Ocean formed. First rivers began flowing. Water cycle established. 2130-2157. Fine-tuning phase. Atmospheric composition optimized. Microecosystems established. First open-air farming began. Today, Professor Chen continued, we've reached a critical threshold. Atmospheric pressure and humidity have reached minimum levels for natural cloud formation and precipitation. The Great Rain Project will trigger this. The Great Rain Project. In the afternoon, Albany and her classmates went to Olympus Atmospheric Control Center, a massive complex, 650 feet high, spread across 5 km². Inside, supercomputers controlling Mars's atmosphere, weather manipulation systems, and dozens of satellite control stations. Chief Engineer Rodriguez, second-generation Martian, greeted the group. Today we make history. We'll initiate Mars's first controlled, sustainable rain system. The plan: orbital heaters vaporize water in Mariner Valley. Ionosphere charge to accelerate atmospheric circulation. Silver iodide seeding triggers cloud condensation. Cooling drones create temperature gradient. Rain begins. At 14 hours, the system activated. Nothing happened for the first 30 minutes. Then clouds began appearing on the horizon. Real clouds. Not Mars's thin cirrus clouds, but cumulus clouds like on Earth. At 1547, the first drop fell. Sensors recorded everything. Drop size 2.3 millimeters. Earth standard 2 to 5 millimeters. Fall velocity 4.5 millips. Earth 9 millips. Low gravity effect. pH 6.8. Slightly acidic but acceptable. Temperature 2°C. Applause erupted in the control room. After 127 years, real rain was falling on Mars. Outside, under the first rain, Albany put on her oxygen mask and went outside. Hundreds of people had gathered outside the domes, hands open, heads up, feeling the rain. Martian children were seeing rain for the first time in their lives. Some were scared. Water falling from the sky was abnormal for them. Old Earthers were crying, feeling rain again after 40 years. Albany extended her hand. Drops fell into her palm. Cold, wet, real. Drops hitting Mars soil created small craters. Dry soil immediately absorbed the water. Perchlorate smell mixed with the air, but nobody cared. It lasted only 15 minutes. Then the clouds dispersed. But it was a beginning. Systems had shown controlled rain was possible. Within 10 years, regular rain cycles could be established. Evening. At Mars Bar. In the evening, Albany celebrated with friends at Mars Bar. The bar was in Olympus's entertainment district. The ceiling was completely transparent. Phobos, Deimos, and stars were visible. Earth was also visible, a bright blue dot, slightly dimmer than Venus. Drinks were Mars-produced. Mars beer, Olympus Brewery. Low-gravity fermentation gives different taste. Cactus vodka from genetically modified Mars cacti. Perchlorate cocktail. Harmless despite the name. Blue-colored. Music played. Mars Symphony No. 3 by Martian composer Lu Wei. Instruments sounded different in low gravity. Piano strings vibrated longer. Drums gave deeper tones. Albany's friend Marcus, from Mariner City, was talking. You know, our grandparents came here as humanity's backup plan, in case something happened to Earth. But we're not backup anymore. We're a new kind of human, Homo sapiens martalis. The debate heated up. What would be Mars's future? Independence? Remain Earth's colony? Someone asked, would you ever want to go to Earth, Albany? Albany thought, would Earth's gravity crush her? Would her bones withstand 1G gravity? Could her heart work in that dense atmosphere? That heavy gravity? Maybe as a tourist, she said. But I'm Martian. This is my world. Night, dreams and reality. At night, Albany lay in bed watching stars through the ceiling. Her grandmother used to tell her stories from Earth about the smell of oceans, sounds of forests, silence of snow. Albany tried to imagine these, but for someone born on Mars, truly understanding what an ocean was seemed impossible. The largest body of water was Lake Mariner, 30 miles wide. Outside, Mars night revealed itself. Temperature had dropped to -45 Tong. The thin atmosphere couldn't retain heat, but inside the dome, a constant 22 Tong. Nuclear reactors and geothermal energy heated the city. Albany's computer signaled. Message from her grandmother, from Earth, even at light speed, 14 minutes delayed. Dear Albany, I heard about today's rain. How proud I am of you. When I first came to Mars, we couldn't even imagine such a day. You and your generation have achieved the impossible. Mars is no longer just a place to survive. It's home. Everyone on Earth talks about the Mars miracle. Maybe one day normal travel between two planets will be possible. Until then, look at the stars and remember me. I love you. Albany closed her eyes. Tomorrow was the presentation of the Grand Canyon project, the plan to fill Valle Marineris with water and create Mars's first real ocean, a 50-year project. When completed, Albany would be 70, but her grandchildren might one day swim in that ocean. Part 4. Technologies of Mars. 257. Life support systems. The survival of Mars colonies depended on interwoven layers of technology. Every system had at least triple redundancy. On Mars, failure meant death. Atmosphere management. Each dome worked like a giant lung, absorbing CO2 in the morning, releasing O2 in the evening. Central atmospheric processing units. Capacity, 10,000 m3 minute. Air processing, CO2 capture, amine-based chemical absorption, O2 production, 40% electrolysis, 35% cyanobacteria, 25% muxi systems. Humidity control, maintained between 45 to 55%. Too low, respiratory problems. Too high, mold. Each citizen had personal carbon credits. Daily allowance of 840 grams O2, 1 kL02 production quota. Extra O2 credits used during exercise. Excess CO2 production meant penalty points. Water cycle. On Mars, not a single drop of water could be wasted. Closed-loop systems operated at 99.7% efficiency. Rowan, 95% recovery. Advanced version of NASA's ISS technology. Sweat and breath moisture, 98% recovery. Gray water, shower, dishes, 99% recovery. Black water, anaerobic digestion, plus UV sterilization. Reverse osmosis. Average Martian used 50 liters of water per day. Earthling 300 liters. Showers limited to 3 minutes. Vacuum toilets instead of flush. Energy production. Mars's energy infrastructure was diversified. Nuclear, 45%. 10 fusion reactors, each 500 megawatts. Panel area, dust cleaning robots. Wind, 15%. Special turbines for low atmospheric density. Geothermal, 10%. Olympus Mons volcanic heat. Backup power. Each colony had 30-day fuel cell reserve. In crisis, daily energy consumption could be reduced to 20%, life support systems only. Transportation systems. Hyperloop Mars. Elon Musk's 2013 dream had become reality on Mars. Magnetic capsules and vacuum tubes. Speed, 620 mph. Olympus Mariner, 2 hours, 1,860 miles. Energy consumption, 90% less than aircraft. Passenger capacity, 28 per capsule. Mars Rovers 3.0. Personal vehicles evolved from 2030's rovers. Range, 620 miles. Methanol fuel cell. Speed, 75 mph. Flat terrain, pressurized cabin. 1 week life support. Autonomous driving. Starlink Mars satellite navigation. Adaptive legs instead of wheels for Mars terrain. Suborbital hoppers for long distances. Rocket planes, any point on Mars in 45 minutes. Methane, Lux fuel, Produced on Mars, 50 passenger capacity. Only needs 1,1600 feet flat area for landings takeoff. Food production. Food security on Mars was vital. Importing food from Earth cost $50 million per ton. Vertical farms. 50-story vertical farm towers in each dome. Garn LED lighting. Red-blue spectrum optimized. Hydroponic, aeroponic systems. Overdo with 40K gear vegetable production. Water usage. 5% of Earth farming. Harvest. 12 times per year. Continuous summer simulation. Crops grown. Potatoes. Can grow in Mars soil too. Soy, protein source. Spirulina, highest calories per area. Tomatoes, lettuce, carrots, for vitamins. Quinoa, resistant to Mars conditions. Protein production meat wasn't luxury, but necessity. But raising animals was impossible. Cell culture meat.
Cell culture meat, 100 bioreactors, 10 tons meat per month. Insect farms, cricket protein powder, mushroom protein, grows in Mars soil. Fish farms, tilapia, can survive in low O2. Closed ecology, everything was recycled. Pratastilio, efficiency, one person's annual food needs, 200 meat-carad production area, plus 50 meat-carad support systems. Communication and social life. Earth-Mars communication, delay problem couldn't be solved. Laws of physics couldn't be changed. Minimum delay, 4 minutes, close position. Maximum, 24 minutes, far position. Average, 14 minutes. Solution, asynchronous communication. Video messages, holographic letters. Instead of live conversation, a culture of deep, thoughtful messaging developed.
Mars Internet. Starlink, Mars. 500 satellites in Mars orbit. 1 Gbps speed within colony. 100 gigabits. Earth connection. Quantum encryption. Latency, 1 den. Social media was different. Mars book local. Earthlink delayed. 2 separate digital cultures had formed. Entertainment and culture. Mars had developed its own unique culture. Sand sculpture. Mars sand. Different from Earth's lakes. Aurora Martialis. Viewing solar wind plus artificial magnetic field. Mars auroras. Health systems. Low gravity adaptation. Mars gravity 38% changed the human body. Bone density loss 1 to 2% per year. Muscle atrophy 20% in 6 months. Heart shrinkage 15%. Spine elongation 5 to 7 centimeters. Solutions: mandatory 2 hours daily exercise. Centrifuge sleeping pods, 1G simulation. Bone density medication. Resistant suits. Constant muscle resistance. Radiation medicine. Every colonist TNA, scanned every 3 months. Mutation detection. CRISPR therapy. Radiation dose tracking. Early cancer detection. Average Martian received 50 times more radiation than Earthling. Cancer rates 30% higher, but treatment technologies had advanced proportionally. Psychological health. Living on Mars was full of psychological challenges. Earth homesickness, only in second generation. Enclosed space syndrome. Red monotony. Everything red. Earth FOMO. Fear of missing out. Therapy. Earth simulations. Artificial nature rooms. Forest sounds. Ocean scents. Mandatory social activities. Earth time rooms. 24-hour Earth cycle. Part 5. Major projects and the future. Valles Marineris. Ocean project. 2,500 miles long. 125 miles wide. 4 miles deep. Valles Marineris was the solar system's largest canyon. Plan: fill it with water in 50 years. Calculations: required water 5 million kilometers to Crete. Available polar ice 3 million kilometers to Crete. Solution: ice import from Europa. Jupiter's moon Europa had twice Earth's water. Nuclear-propelled ice asteroids would be brought to Mars in 10-year journeys. When completed, Mars's first real ocean, 800,000 kilometers surface area. Local climate change, water sports. Phobos space elevator. Mars's inner moon Phobos orbits just 3,700 miles high. Earth's space elevator dream was easier on Mars. Technical details: carbon nanotube cable, 3,700 miles. Counterweight on Phobos. Transport capacity, 100 tons per day. Launch cost reduction, 99%. Planned completion in 2180. would transform Mars into a true space hub. Atmosphere thickening phase 2. Goal: 21% O2, 101 kPa pressure. Earth standard by 2200. New technologies: Ronomania, comets from Kuiper belt, to all-2 transfer from Venus, via aerobraking, artificial volcanism with super-efficient fusion reactor, genetically modified super cyanobacteria, calculated time, 43 years. Mars would be breathable without masks by 2200. Mars moons colonization. Phobos and Deimos were Mars system's natural space stations. Phobos base, Ren Mars Nile, Ren Mars 1, Ren Mars Howlus Production Sefser Center, Scientific Observatory, 500-person crew, Deimos Fuel Station. By 2057, Mars population had reached 1.2 million. Economically, 60% self-sufficient. Political debates had heated up. Pro-independence. Mars-born now majority. Different living conditions. Different governance. 40% of taxes go to Earth. Decisions arrive 14 minutes delayed. Pro-union. Rue live. Pro-union. Still dependent on Earth technology. Security. Asteroid defense. Cultural ties. Economic partnership. Referendum. Planned for 2160. Polls showed 52% independence. Epilogue. Humanity's second home. October 15, 2258. 100 years later. Albany Jang was 123 years old. Still active thanks to Mars medicine. As mayor of Olympus City, she was giving a speech at Mars's centennial celebrations. The landscape had completely changed. Looking out the window, blue sky, still slightly reddish, white clouds, green plains, distant shores of Valles Marineris Ocean, silver ribbon of Phobos space elevator. 100 years ago, Albany began. When our grandparents set foot on this red desert, they fought to survive. Today, 10 million Martians, 2 million Earth tourists, and the first asteroid diplomat are in this hall. Mars is no longer a colony. Mars is a civilization. The hologram showed statistics. Population, 10.3 million. 7 million Mars-born. Number of cities, 127. Atmosphere, 45 kPa, 15% O2. Average temperature, -52 Golfc. Habitable area, 50 million kilometers quadrille. Habitable area, 50 million kilometers quadrille. GDP, 500 trillion Mars dollars. But our greatest achievement, Albany continued, isn't creating a new human species. Our greatest achievement is making Mars home. Our children no longer feel homesick for Earth. For them, this is the home planet. At the ceremony, the first Mars-Earth marriage was celebrated. Jennifer Chen, Earthling, and Marcus Sang, Martian, were getting married. What planet would their children be citizens of? The new constitution had created dual planetary status. Final message. As Albany finished her speech, a message from Earth appeared on screen. UN Secretary General. Dear Martians, you are humanity's greatest achievement. You didn't just survive, you thrived. You didn't just colonize a planet, you gave it life. Mars is now humanity's second home. And who knows, maybe one day we'll repeat this ceremony on Venus, Europa, Titan, because you've proven humanity is not limited to one planet. Albany turned to the window. Outside, the first Mars-born birds were flying. Genetically modified pigeons, able to fly in thin atmosphere. A child approached. Her great-great-grandchild, fifth-generation Martian, 7 feet 3 inches tall, long thin fingers, large eyes. Evolution had accelerated. Great-great-grandmother, said the child, would you ever want to go to Earth? Albany smiled. Once I would have, but not anymore. This is my home. This is all our home. Outside, the sun was setting, that small, pale sun. But the second sun, the artificial sun, reflected from orbital mirrors, shone in the sky. Mars now had 2 suns. And for the first time, a real rainbow appeared. Water droplets were refracting light. The red planet was no longer red. Mars was alive. Conclusion. Science and imagination. Real NASA data. The terraforming process described in this story isn't fantasy. It's based on NASA's real calculations. 2021 NASA terraforming study. Trend 221 NASA Terraforming Study. 202 reserves on Mars, enough to thicken atmosphere threefold. Water reserves, 5 million kilometers through keep confirmed. Required warming, plus 40 Direxi. Possible duration, 100 to 300 years, depending on technology. Current technologies, MOXIE, real, working. Orbital mirrors, tested on ISS. Nuclear propulsion, under development. CRISPR, Mars bacteria created. 2024, Mars data. Perseverance, found organic molecules. InSight, detected liquid water layers underground. Mars sample return, samples on Earth in 2033. SpaceX Starship, crewed Mars mission in 2029. Why Mars? Mars isn't Earth's plan B. Mars is the next chapter in humanity's evolutionary story. Just as our ancestors left Africa and spread across the world, we will spread to the stars. And the first stop is Mars. Because Mars' day is 24.6 hours, we can adapt. Has seasons. Agriculture possible. Has water. Has life. Atmosphere can be thickened. Gravity is tolerable. Challenges and realities. But it won't be easy. NASA's reports are clear. 10% of first colonists will die in first year. Cancer risk increases 5-fold. Psychological problems inevitable. Cost, $500 trillion, spread over 100 years. Ethical issues. Do we have the right to Mars? Final words. We'll set foot on Mars in 2030. First permanent base in 2050. First city in 2100. Million population in 2150. Habitable planet in 2200. This isn't a dream, it's a plan. NASA, SpaceX, ESA, CNSA, they're all working according to this plan. Maybe one of you watching this video will be among the first Mars colonists. Maybe your children will be born on Mars. Maybe your grandchildren will look at the two-sun sky and call it home. Carl Sagan said, Mars is humanity's future home. Now that future is only 6 years away. Mars is waiting. Are we ready?